Okay, so we're going to be looking at virtual machines in this video. One of the key things to remember before we get started is virtual machines and virtual memory are not the same thing. I've seen plenty of exam questions where people have tried to answer virtual memory by writing about virtual machines and vice versa. Just make sure they're nice and clear in your notes. I know you go through them and they're completely different things, but people do sometimes mix them up. We're going to be looking what virtual machines, which is any instance where software is used to take on the function of a machine, including executing intermediate code or running an operating system within another, and learn the difference between what's known as a process virtual machine and a system virtual machine. One of the things from past experience the exam board like is intermediate code. So we're going to be spending a fair amount of time looking at what that is. So we're going to be looking at what a virtual machine is first. So a virtual machine, it will run on a standard PC and we call it the host. So that's the PC that's running the virtual machine. It's self-contained operating environment which makes use of the host hardware. It requires software in order to run it, so we call that the virtual machine. It abstracts or virtualizes the hardware of the system and acts as a bridge between the real hardware and the virtual one. And programs running in a virtual machine are sandboxed, meaning that they can only access the host hardware via the virtual. And here's a little diagram to represent it. So on the right-hand side here, I've got the host operating system. So I've drawn it as kind of an enclosed box. Inside it, you have the virtual machine. The virtual machine will effectively just be another program running on your system. And I'll come into what that is at the moment, in a moment. So the operating system is going to have device drivers which talk to the devices. So when we're looking at the operating system, we looked at what a device driver is and how that communicates with the devices. And the host operating system is obviously going to be managing that. Our other apps are going to be running in the operating system. So if an app is trying to use the hardware, it will talk directly to the operating system, and then that will talk to the device driver and then talk to the devices. So the request will go to the operating system, to a device. So let's say the hard drive, let's say I'm trying to save something, and then that will finally get translated into something the hard drive will understand. So that's how normal applications will work. Virtual machine is a normal application, but however, there's going to be other programs running within it, and that's the kind of. So we have this idea of a guest operating system. Now that could be a different operating system, like Linux running inside Windows, or Linux running inside Mac, or Windows running inside a Mac, whatever happens to be. But that operating system is running inside the virtual machine. So that virtual machine can talk to the host operating system, but the guest can't. It has to talk to the virtual machine first, which will then talk to the operating system. So let's say I'm in Linux and I'm trying to save a file inside the virtual machine Linux. It will send the request to the machine first. That request will then get the operating system. Then the operating system it to the device driver and away we go, and it will save. So there's that extra little step. So when we say sandbox, what we really mean is that the guest operating system has to abide by the rules of the virtual machine. It can't access the real operating system without help from the virtual machine. So if the virtual machine says no, you can't access the hard drive, then it can't. Okay, so virtual machines such as VirtualBox, things like that, allow you to control precisely what devices and how much hardware the virtual machine can actually access. So because the virtual machine software acts as an intermediate step between the guest operating system and the host operating system, it can do some extra processing. So it allows us to add extra security. So if something bad happens within the virtual machine, we can isolate it. As the file is used to represent the guest operating system hard drive, the guest operating system is unable to access anything outside it. So when we create a hard drive within the virtual machine, it effectively is just one big file, and the guest operating system can't access anything out of that file unless you tell it it can. Okay, so you can actually share folders and things like that, but you have to say it precisely. So you can specify what hardware the virtual machine has, as I said before. So now's the perfect time to pause the video and have a go at a little practical task. So The best way to learn about virtual machines is to have a play with one. So if you download VirtualBox, which is free, and then download a virtual disk for it called Puppy Linux. Now, Puppy Linux is a distribution of Linux which is really, really small. It has a very small footprint. It doesn't need much resources, and it's ideal for less powerful computers. The reason why I've picked this one is because when you run any kind of virtual machine, they tend to run a bit slower, well, a lot slower if I'm honest with you, especially if you haven't got much RAM in your computer. So open VirtualBox and then open up that virtual machine, start it up, and then try and do something with it. So I'm suggesting maybe just create a little text file, save a file, and when you save a file, you'll notice you'll have a completely different file system, so you won't have your normal C drive and everything like that. And just have a work out where do you think that file has been saved to. So we're going to have a look at the difference between a process virtual machine and a system virtual machine. So in a system virtual machine, we'll have a guest operating system and a host operating system. So in this case, I've got a Mac OS as the host, and inside that we've got Linux running. Okay, so it allows me to run an entire new operating system from within the host. So it will allow full access to the operating system. It has to work on the same CPU architecture. It doesn't emulate CPUs in any way, shape, or form. So if you've got a desktop PC, so x86, you have to use an x86 operating system. So that, for example, means you can't run iOS as a virtual machine inside Windows. It's just not going to happen. The virtual machine will then create a bridge to the host hardware. So again, open up your Puppy Linux, have a little practical, and have a go at looking at what hardware is. Now, these commands in Linux allow you to see a number of different parts of the hardware. So LSPCI is going to list out all of the PCI boards, or things like sound cards and things like that. LSUSB is going to list out all the USB devices connected to it. CAT proc CPU info is give you detailed information about the CPU that's being used, and meminfo will give you detailed information about memory. Okay, so it gives you a lot of information. One thing to do with this is compare it to the real hardware. You'll notice that they're not all the same, okay, because some of them are being virtualized. So now's a good time to pause to make notes on what a system virtual machine is. Explain the terms guest and host, so you've got that nice and clear in your mind. Describe how hardware is virtualized and what we mean by the word sandboxed, okay, because those are two really core concepts. And do practice playing around with them, because the best way to get to grips with what a virtual machine is and how it works is by doing those two little activities I've just previously suggested. Now, then the last part of this is going to be looking at process virtual machines. So this will execute within a single program and will be written in intermediate code. When running normal software, you would compile the program into machine code. So if I, for example, wrote a program in C++, I compile it, it would create a machine code executable, I can then run it directly. For process virtual machine, however, you compile it into something called intermediate code instead. Now, this is code which doesn't actually run on any processor out there, which sounds a bit weird. I'll explain what that really means in a moment. But process virtual machines acts as an interpreter. So the process virtual machine will run a single program, and it interprets the intermediate code here and runs it on the actual host CPU. Intermediate code always, and I do mean always, requires an interpreter to run it, the virtual machine. Okay, it's designed to run on a completely generic CPU. Okay, there's no CPU out there that runs intermediate code directly. It can be created by lots of different programming languages. So I could, for example, generate intermediate code using C#, and then maybe another language, and then put them all together to make one single program. So different parts of the program could be coded in those different languages, and then all brought together to produce a single program in intermediate code. So let's have a look at what we mean. So here I've got two programs, okay? Both are hello worlds. One's written in C, okay, and that's this one here. And The other one is written in Java. Okay, Java is a classic programming language which is both compiled and interpreted, and it uses intermediate code. In Java speak, we call the intermediate code bytecode. So if you did some research on this, you'll probably see the term bytecode used instead of intermediate code, but it is, in sense, intermediate. Because I'm a bit of a geek, I disassemble stuff. If I disassembled that hello world, okay, this is what gets generated. I disassembled this on a Linux computer, so you'll probably get something different if you did this on Windows. But you can see this is machine code. Okay, so these are the assembly code instructions. And on the other side, I've got the Java bytecode. Now notice straight away, the Java bytecode looks a lot simpler. Okay, it's not as techy. You can almost read it. I wouldn't say you fully understand it, but you can get to grips with it. While the C1 is probably gobbledygook to you. But notice that the same program is generating very different code. Okay, so the Java intermediate code and the actual machine code up here. So intermediate code versus machine code. Generic code, intermediate code is generic code not to run on any CPU whatsoever. It's not designed for any operating system, and it requires a virtual machine in order to interpret it, in order to run it. Machine code, on the other hand, is designed to work on a specific CPU instruction set and will make use of specific operating system libraries. This means that any machine code generated will only run on a very specific architecture and a very specific operating system. It won't run on anything else. So it's going to run directly as long as the OS and CPU is correct. If they're not, obviously it won't run. So Java programmers, once compiled, make use of a virtual machine in order to run the programs in the form of intermediate code. This long answer question is a very good one to practice. So describe what is meant by intermediate code and discuss the relative merits and drawbacks of Java using intermediate code, giving your overall opinion. Okay, and this is the kind of question you could get asked about this topic. So let's think about how we're going to go about answering this question. Okay, so in order to get the marks for long answer questions, you need facts, application and evaluation. So here's some of the facts. Intermediate code is not machine specific, it's going to be compiled. So that's describing what intermediate code is. Virtual machine is a theoretical computer used to interpret the machine code, and intermediate code can be compiled once running any system. So down here, this is one of the key benefits of it. Application, meaning it requires interpretation to be run, so I have to interpret it before I can run it. It hides the source code. Now, because I've compiled intermediate code, I gain one of the advantages of compiling, which is hiding the source code so nobody can read it. It's going to be sandboxed, so we get extra security. Remember, virtual machines allow us to control what hardware gets used. And it abstracts differences between the operating system and architecture. So I don't need to worry about the operating system, the libraries installed, or anything like that. It will just simply run as long as it's got an interpreter. And then you've got to, for evaluation, have a logical conclusion and back it up by evidence. So in order to get top marks on this, candidates should be able to describe what's meant by a virtual machine, how they can be used to execute intermediate code, how they can be used to run a software-driven machine instead of a physical machine, and the benefits and drawbacks of each approach. Okay. Notice that they don't use the term system and process virtual machine. These are the terms used on the internet if you do any research on this, so I've borrowed those terms, and I think it's a nice way to think about the differences between a system and process virtual machine. So I think it's useful to know that, although you won't necessarily get tested on that.